I must start. Oh. Okay. Sorry. Okay. Then now we have next report. Sergey Lienkov, Serhii Shvorov, Oleksandr Sieliukov, Igor Tolok, Nataliya Lytvynenko. They absent, therefore we will show their video. If you please take a look. I will start.
Dear colleague, I would like to present to you the main results of the research deep learning of the neural networks using genetic algorithms. The purpose of the research is to develop the scientific and methodological foundation of learning neural networks using genetic algorithms. As you know, an artificial neural network is a set of interconnected neurons. The transfer functions of all neurons in the network are fixed, and the weight are parameters of the network and can change. Some neuron inputs are labeled and external inputs of the network, and some outputs are labeled and external outputs of the network. Thus, the work of the neural network is to transform the input vector into the output vector, and this transformation is given by the weights of the network. Almost any problem can be reduced to a problem solved by a neural network. At the same time, the construction of the artificial neural network is solved in two stages: choosing the type of the network, selection of the weights of the network. In the first stage, the following should be determined: what neurons we want to use, how they should be connected to each other, what to take as a network inputs and outputs. At first glance, this problem seems unsolved, but it isn't necessary to invent a neural network from scratch. There are dozens of different neural network architectures, and the effectiveness of the many of them has been proven mathematically. At the second stage, the most difficult task is solved. It's necessary to teach the selected network, that is, choose such values of its weights so that the network works as required. For many architectures, special learning algorithms have been developed that allow to adjust the weights of the network in a certain way. However, for complexes, artificial neural networks architectures, solving the problem requires further research. Solving the problem of deep learning of neural networks is especially relevant. Analysis of recent research and publications shows that depending on the functions performed by neurons in the network, three types can be distinguished. input neurons, output neurons, intermediate neurons. In most neural models, the type of neurons is related to its placement in the network. In the process of functioning of the network, the input vector is transformed into the output vector. That is, some process of information is carried out. The process of functioning of a neural network and the set of actions it can perform mainly depends on the values of synaptic connections. That's why, having determined the structure of the network corresponding to the chosen problem area, the optimization of the weighting coefficients in real time in a genome task. Its ability to function qualitatively and adequately depends on how effectively the neural neurons training will be performed. The result of adding is shown on the slide. The main functional purpose of the artificial neural networks is the transformation of input signals into output signals. In this case, the neural network is presented as a multi-dimensional function. Experiments of learning neural networks have shown that known methods of local and global optimization require a significant number of learning steps, are sensitive to the accuracy of calculation, require a significant number of additional variables. Therefore, the research and development of new methods is urgent task training of neural network. Therefore, there is a need to use such approaches, which would not have the mentioned disadvantages. Genetic algorithm stands out among optimization mathematical devices in the context of the given task. The purpose of the work is to develop the scientific and methodological foundation of learning neural network using genetic algorithms. To achieve the goal, the following tasks were solved. To justify the approach to learning neural network using genetic algorithms, to solve the optimization problem of learning using the genetic algorithms on the example of forecasting the time series of temperature of the natural environment by the method of shortest descent. Research materials and methodology you can see on this slide. When learning a neural network, the problem of error minimization is set number 2. If the network doesn't make errors, that is the goal of learning neural network is the task of finding the minimum of error function. In order to increase the reliability of decisions made on the basis of a neural network, it is necessary to investigate alternative optimization algorithms that allow finding the global extreme. Therefore, there is a need to use such approaches that wouldn't have the indicated disadvantages. The considered genetic optimization algorithms are the most promising in this regard. To minimize the learning error of neural network based on genetic algorithms, each variant of the vector of weighting coefficients is matched with some chromosome, presented in the form of the bit string. In the selection process, a directed search is made for chromosomes that provide the extreme of a given objective function. As a neural network learning error function is used in the neural network training procedure. The concept of learning neural network, when using a genetic algorithm, is in contrast to traditional learning methods, has a different meaning. Learning here consists in applying genetic operators to the genotype of the vector. That is, to a chromosome in the training sample serves to calculate the learning error of the neural networks with specific values of the weighting coefficient. The scheme of the genetic algorithm of the learning neural network procedure is presented on this slide. When solving the problem of forecasting the time series of temperature of the neural environment, an appropriate neural networks were synthesized where the input and output values are the temperature values. To implement the learning algorithms of the neural network with the help of genetic algorithms, It will use a network with the smallest errors. Architecture of neural networks, forecasting of temperature times series is presented on this slide. The parameters of solved problem are the weighting coefficient. To minimize the learning error of the neural network based on the genetic algorithm, we will match each variant of the vector of weighting coefficient with a chromosome present in the form of a bit string. Symbolic representation of fixed variable value in a binary code is shown on this slide. Symbolic notation of the solution vector is presented on this slide. A binary combination is taken as a gene that determines the fixed values of the parameter in a binary code, and the smallest indivisible unit amenable to evolution is a person. The chromosome that has specified values of alias its loci is called a genotype that contains all the hereditary genetic information of a person. The finite set of the admissible genotypes is a gene pool. The assessment of the fitness of chromosomes in the population will be determined by calculating the membership function for each chromosome of this population. The assessment of the fitness chromosomes in the population will be determined by calculating on the member functioning for each chromosome of this population. The fitness function always takes a non-negative value in addition to solve the optimization problem that function needs to be minimized. A collection of individuals forms a population. The goal of population evolution is to increase the average value of the membership function of the population. Thus, the optimization procedure using the genetic algorithm iterative as across the two stages: the synthesis of new chromosomes, the selection of chromosomes, and a new population. The process continues until the optimal solution and the given number of generations are obtained. The solution of the problem corresponds to the chromosome with the minimum value of the membership function. The optimal weighting coefficient of the multilayer perceptron type neural network with two neurons in the hidden layer were determined using a genetic algorithm with the following parameters that are presented on this slide. The obtained results show that the speed of approaching the extremum is high and increases with the increase in the number of populations. It's also possible to draw a conclusion about the low percentage of experiments in that exact value or the minimum of obtained, depending on the total number of runs of the genetic algorithm, that is, on the number of population. Analyzing the projections of time series of temperature, it should be noted that a neural network relatively correctly predicted its decrease, increase, and stabilization. When forecasting a day ahead, in general, there is an increase in the accuracy of the forecast of a neural network using a genetic algorithm compared to a conventional neural network. Though the following conclusions are experiments of learning neural network showed that known methods of local and global optimization require a significant number of learning steps. In most cases, they make it possible to find a local rather than a global extremum. That's why the search and development of new methods of learning neural networks is a joint task. In order to increase the reliability of discussions made on the basis of the neural network, it's necessary to investigate alternative optimization algorithms that allow finding the global extremum. The genetic optimization algorithms are the most promising in this regard. The scientific and methodological foundation of learning neural network are developed in the paper. The study of the effectiveness of the application of the genetic algorithm to optimize the function and deep learning of neural network in operation established the perspective of such of approach for biotechnical complexes that are exposed to external disturbances. Thank you for attention.
So it was a video.
Yes, it was video and nobody present.
So we cannot ask questions, unfortunately. So please contact me also via the email if you have questions about this presentation on neural networks. I think we should also...
Only comment from all present. In my opinion, unfortunately, that genetic algorithm approach is not new for neural networks.
Yes,
In
it's
my
true.
opinion, authors should be include a review previous here before
Yes,
present. And
probably
in my
this is the
opinion,
case.
that new results is only used for concrete tasks.
Yeah, you are
Okay,
right.
we will note this and inform authors that they should consider other approaches and how they differ from previous approaches of genetic algorithms. I think also from my own knowledge, it has been applied, but maybe in a different way. So it needs a review. Okay, we have noted, and I think we should also continue with the following presentation because time is moving fast.
Time. And Vadym Slyusar, take your time.
Yes, if possibly, could you take my video records because I have
okay, I will try.
stability connection.
I understand.
Thank you. I will answer after the video records.
Sure.
Okay. Looking for your report. I'm not fast enough. One moment. This one, yes.
Colleagues, we invite your attention to a report on the topic segmentation of analog matter readings using neural networks. As you know, one of the constraints to the implementation of the concepts of smart home, smart city, industry 4.0, agriculture 4.0, etc., is the need to integrate analog energy metering, for example, water, gas, and electricity meters. Often the replacement with digital devices is not cost-effective. This may be due to the ban of making change to communications, the high cost of development, design and technical documentation, a large number of analog accounting tools at the enterprise, etc. One option to overcome this barrier could be a combination of artificial intelligence and Internet of Things technologies. At the same time, an optical channel for digitizing readings based on the recognition operation is very often used to transform analog matters into digital ones. However, we have significant drawbacks that affect mass adoption. Here it is necessary to indicate high requirements for the spatial stability of image and exposure parameters, the lack of unification by types of counters and fonts, and the influence of vibrations with certain specifics of technological production processes. In addition, the user-age computing has to adjust to limited computing resources, low-resolution images, typically around 28 by 28, the need for manual segmentation, accurate initial setup, and manual correction of reading data. One of the options for solving this problem can be use of an image segmentation procedure before recognition. The technical implementation of this approach is possible due to fork computing technologies. The aim of the work is comparative analysis of the accuracy of possible options for solving the problem of semantic segmentation of images of digital displays of counters based on neural networks. Using this architecture of the so-called large PSP, we will consider this approach as a starting point for research. It should be noted that the choice of one or another format of the recompressed image, in addition to the maximum possibility of maintaining of proportions of the original image of the database, should also take into account the existing limitation of the computing resources on which the neural networks are trained. To maximize these resources, the study used the graphical mapping capabilities of Google's Glob Pro Plus Surf in Learning. The learning process of the PSP neural network was performed with a learning step of 0.001 and batch 16 seeing the installation of batch 32 was accompanied by an insufficient resource error. The learning dataset contained H70 images, and the validation dataset contained 374 images. The masks used for image segmentation were black and white. The percentage of space occupied by the black background was 90–80%, while the white cathode for digital display counted for 2%. The runtime for 200 learning epochs is standard Google Glob Pro Plus connection mode with V100 graphics card equipped with 16 GB of RAM was 32 minutes. Next, we explored the option of modifying the original PSP architecture by replacing the conv2d transpose layers with upsyncing and max pooling with average pooling. Even greater improvements in accuracy were achieved by using a modification of the PSP network, which consisted in increasing the number of convolution layers with the ReLU activation function in each of the channels up to 8. The size of the cores remained the same 3 by 3, fixed for all 4 channels. Pooling branches also remained, and the number of convolution kernels is 60. In this case, both normalization layers were used in each channel, and additionally a droplet layer with a data thinking factor of 0.1 was applied at the channel output. This structure has been given the conventional name PSP Block 2D. As a result of learning for 116 epochs, the accuracy of the class with the worst segmentation quality on the test sample reached 73%, and the average class accuracy reached 86.2%. In left figure illustrates the learning process described, and right figure the segmentation quality on the validation set. At the next stage, the studies were carried out using a neural network of the UNet type. This figure shows the architecture of the light version of UNet. The relative simplicity of its architecture made it possible to switch to the original 432 by 240 pixel dataset and easily carry out long-term learning for 6 to 2 epochs with a batch of 60 and final learning step of 0.0001. The calculation time of one epoch fluctuated within 27-28 seconds. Already at the 5th epoch, an accuracy of 88.4% was achieved, and then it took more than 400 epochs for the maximum achieved accuracy to stabilize at the level of 88.8% at the 4th epoch. Not only the architecture for the neural network contributed to the improvement in accuracy, but also the larger image format during learning. Further complication of the architecture was carried out by switching to a neural network of the U-Net++ type. In the course of computational experiments, it was found that with neural network work with BAT4, but not as efficiently as a large and medium U-Net. As you might expect, BAT8 at 0.001 gives better accuracy than BAT4. Also, U-Net++ works on BAT60, but much worse at 0.001. The resulting accuracy for different BAT sizes is presented in table. The so-called U-Net was considered as a maximum complexity of the neural network architecture. In this case, a 240 by 432 pixel image dataset made it possible to work with batch 4, 8, and 60. The maximum accuracy with BAT60 and a learning step of 0.001 was 86% at the 8th epoch, and with BAT8 it was 88.5% at the same epoch 18. Thus, the U-Net neural network demonstrated more intensive learning. On this slide is presented a comparison of the architectures of all considered neural networks. As you can see, a larger architecture doesn't necessarily give a better result. The hardware implementation can be based on the Raspberry Pi Zero processor board, the neural network on the ESP32. Alternatively, you can use the ESP32CEM module, which is currently the most cost-effective option for implementing edge IoT. Given the relevance of edge computing, it is advisable to explore the possibility of implementing segmentation and recognition based on TensorFlow Lite on devices such as ESP32CAM. The approach considered in the paper can be used not only in the interest of creating digital infrastructure. A promising direction is the development of uncrewed platforms that use vehicles initially oriented towards human control. At the same time, to read the indicators of the sensor, for example, a speedometer, engine speed, oil pressure, etc., video cameras with neural networks can be used similar to the options discussed here for household matters. The authors plan to continue further research on the possibility of using neural networks based on the use of object detection technology with making digital displays using bounding boxes using the results. This is the concluding of my briefing. Thank you for your attention.
Thank you.
Thank you. So did you see, can you quantify the performance drop when you go to a TensorFlow Lite architecture that runs on a Raspberry Pi, which I find quite impressive. What would you say is the performance drop with respect to classical neural networks, deep neural networks?
Raspberry Pi, it's enough for using deep learning networks such as small unit architecture. It's can then upload to Raspberry Pi. And another approach can be transfer data from matters to desktop computer via telecommunication links.
Okay, so you do the training on a fast computer and then transfer.
Yes, yes.
Okay, I understand. Yes, of course, this should speed up a lot, or much less resources needed for the execution of a trained model. Okay, thank you.
Thank you.
Yeah, next reporter is absent, I see. Nataliya, Boyko, Yaroslav, Rohan, Svitlana, Honchar, no present. I'm afraid again we should show video, but it will be shorter. We must be in time, and I'm afraid some fragment of video we will show you now. Moment. They write it 15 minutes. It's too much, much too much.
Estimation of distribution density for large statistical datasets. Introduction. The distribution density function is a fundamental concept in statistics that provides a natural description of the distribution for any random variable and allows the identification of the corresponding probabilities by ratio. In this work, we attempt to determine the 3D density distribution of galaxies in large surveys in order to study the effect of the environment on galaxy evolution. This paper examines the performance of 4 distribution density function evaluation methods: K nearest neighbors, 3D implementation of adaptive estimation of Gaussian nucleus density called DEDICA, a modified version of the adaptive Brayman core density estimation called the modified Brayman estimation, Delaney tessellation field estimator. Description of KNN. The KNN estimator is well known in astronomy, and its principle is to focus a spherical window on each point R and allow it to grow until it captures K samples, K nearest neighbors R. Then the estimate of density KNN for a dataset with n data points is determined in any R. Formula 1. The KNN approach uses a different window size for each point, so it adapts to local density. When the density is high near R, the window will be small, but when the local density is low, the window will grow to a larger size. Description of MBE. Brayman described the case of an adaptive nucleus. This method begins by calculating the distance to the car's nearest neighbor of each data point located on REs, similar to the density estimator KNN. Instead of using this distance to calculate the KNN density estimate, it uses it to control the local core size in the adaptive core density estimate or in the Parson estimate. To sample Dn from endpoints with position vectors and the nucleus, the adaptive density of the nucleus is estimated by Formula 2. In the modified version of equation 2 becomes Formula 3, where K is the exponential core defined as Formula 4. Description of DEDICA. Pisani proposed a kernel-based density estimation method for multivariate data, which is a continuation of his work for the universal case. Again, this is an adaptive kernel evaluator. The main difference of the MBE method are that the Gaussian core is used and that the optimal bandwidths are determined iteratively, minimizing the cross-checking estimate. The study uses a 3D density estimator DEDICA, which is an implementation of Fortran Pisani. For a sample of dn from endpoints with position vectors and a core wise of the eth point given sigma e, the adaptive estimate of Gaussian core density is given by formula 5. Description of DTFE. DTFE is a well-known in astronomy method of density fields reconstructing from a discrete set of scattered points. In this method, the Delaney tessellation of points is first constructed. Then, the density of a point is defined as inverse to the total volume V of the surrounding tetrahedra of each point multiplied by the normalization constant. To sample dn from n points with position vectors, the DTFE density estimate is given by formula 7. Modulated datasets with known density fields. We start by constructing 6 simulated datasets with known density distributions. Simulated dataset with known density distributions is shown on figure 1. Dataset 1 is the unimodal Gaussian distribution with added uniform noise. Dataset 2 contains 2 Gaussian distributions with the same number of points, but different covariance matrices and different centers. Dataset 3 had twice as many points as datasets 1 and 2. Dataset 4 contains a wall and thread-like structure. The x and y coordinates of the wall-like structure are derived from the uniform distribution, and the z coordinate is derived from the Gaussian distribution. Dataset 5 contains 3 wall-like structures, where each wall is created with a uniform distribution in 2 dimensions and the Gaussian distribution in the third. Dataset 6 contains points derived from the log normal distribution. The representation of the scattering graphs of these datasets is shown on figure 2. Astronomical datasets with fields of unknown density. The first astronomical dataset consists of a L-galaxy experimental model Millennium sample. Simulation Millennium is one of the largest simulations that has ever studied the evolution of the universe. It was created to predict the scale structure of the universe and compare them with observational data and astrophysical theories. This dataset is referred to as the MSG dataset, which contains 53,918 points. In this visual representation, the simulation output looks like a thin, three-dimensional fabric of threads with fractal self-similarity and several layers of organization. Experiments. Firstly, we studied the effectiveness of 4 density estimation methods on 6 simulated datasets and then on 2 datasets obtained by MSG. The effectiveness of the methods for artificial datasets in upper rows of figure 4 is compared using ICE and GKLD indicators. True density is the parametric density calculated from the parameters used to create datasets. It is clear that the methods based on adaptive core, MBE and DEDICA perform much better than KNN or DTFE in restoring the density distribution of the input data. For all but the dataset 6, the log normal distribution, the performance of the MBE is better or approximately equal to the efficiency of DEDICA. It is worth noting that the MBE density was calculated by automatically selecting the core size, and the best MBE performance can be obtained by changing the anti-aliasing setting manually. Simulated datasets. It can also be noted that DEDICA works very poorly for dataset 4, where it is not possible to estimate the proper density. Studying the density of points in figure 5, it is seen that DEDICA underestimate the density in the wall. This is because the correct kernel size could not be selected during automatic selection of the kernel size on this dataset. Similar behavior is also observed when considering MSG and SDSS datasets. In addition, the field produced by KNN is not normalized. 4 datasets from 1 to 6 fields on average are approximately 25–30% excessively dense. This is why KNN performs the worst in terms of integral square errors on these datasets. MSG datasets, Part 1. The performance of the density estimators on the MSG datasets in the lower rows of Figure 6 is compared. DTFE is expected to work best on the MSG DTFE dataset, and MBE works best on the MSG MBE dataset. Interestingly, KNN works in the same way as DTFE on the MSG DTFE dataset. This is not a complete surprise, as DTFE and KNN are conceptually similar, as both use only points in close proximity to the current location for direct density estimation. Because of this, both can work better than core estimates, with strong gradients on either fundamental density gaps. Nevertheless, the MBE works in much the same way as DTFE and KNN on the MSG DTFE dataset, suggesting that the MBE continues to operate even especially complex datasets.
Sorry, you have a clue, and the rest you can see in the YouTube. Now we have no time for rest of this video, and we have no anybody who can answer our questions. It may be interesting, but it should be connected with others. And let me introduce next reporter, Oleksiy Oletsky, waited for his word.
Well, good day. I am sharing my screen.
Please.
The sharing is disabled.
Yeah, maybe we'll check. Why it is
Host disabled attendee screen sharing.
Please try again.
Well, thanks.
Hello.
Well, do you see my presentation?
No, not
yes, not yet. Yes, now I see.
Now we see, yeah.
Well, this is a development of a specific model aimed at a multi-agent decision-making, the probabilistic decision-making. And this model places emphasis on the behavioral aspects of decision-making. Decisions are made by each agent with certain probabilities, which should be calculated, and there are agents of influence who are trying to affect the behavior of other agents. The model can be used for modeling behavior of people in social systems and for agent-based systems of algorithmic decision-making. It's very important to examine the problem of equilibrium of alternatives and to find some condition for this. Equilibrium of alternatives takes place if there are equal probabilities for each alternative to be chosen. And it is especially important if there are two alternatives, decisions are made collectively by majority of votes, and there are amount of voltage of agents large enough. Then in practice, equilibrium is the only possibility for alternatives to be chosen in turn. Otherwise, otherwise one alternative will preserve steady advantages over the others. So looking for situations of equilibrium is an essential point. The basic model for simple one, not the model for simple one-step decisions. We introduced some states corresponding to possible distributions of probabilities of voting, and we build a matrix state probability of choice, which elements are the probabilities of choose certain alternative when being in a certain state. And this vector specifies probabilities of being in each state. And then making decision comes down to such a operation over vectors and matrices, and probabilities for input states may be specified directly, but they can be found from a Markov chain describing transitions between states. And this Markov chain is just a modeling of changing of agents' behavior. But typically, decisions are made by on the basis of different factors affecting each other and the final decision. And we propose to build a network of nodes. Each node relates to a separate effective factor, and for each node, its own model state probability of choice should be implemented. It is the more formal description of the model. For each state, we have to specify its own system of states, and we should to specify connections between two neighboring nodes. Terminal nodes need a special treatment. A fuzzy approach can be applied to build such matrices for those nodes. This is described in the paper, but anyway, we have for the simple act of reasoning is
Hello? Freezing.
Hey, we cannot. He's frozen. Let's wait a moment. Maybe some connection. Hopefully not power outage again.
He connected from Kiev, if possible.
Yeah, it's possible, yeah.
It's every time a risk of disconnection. Sorry.
Yes, indeed. What we can do is maybe to wait for the time of the presentation if we come back. But do we have the video? You can play
Maybe
from
this time I try to start from this place.
yes, from the middle. Mhm.
If I will be in.
We have still 10 minutes left, so
Yeah, we have a few minutes. One moment, where is my list. One moment, I will share screen. I will share my screen. No. I don't know, is it my screen or not mine?
No, you haven't shared the screen yet.
I know. This way, and then try to share my screen. You see screen, but again, maybe I must place like share sign. Yes.
Yes.
Then in practice,
But
A bit further. It was 9. Maybe we can further. Yeah, here. Okay.
multiplying on vector and matrices. For example, for the single rule, output vector of probabilities can be calculated by multiplying input vector of probabilities on a matrix or in other form. Certainly, the chain of reasoning may be longer, and it is very important to discover situations when equilibrium holds. If the vector of input probability is symmetric and all the matrices in the chain are centrosymmetric. There can be another situation which needs combining evidence. It is the situation when the same corollary ensues from many premises. Then we can get vectors induced by each rule by a similar formula and combine them by introducing some weighting coefficients, and these coefficients may reflect the degree of trust to different evidences, and again result about equilibrium of alternatives if aggregated matrix is centrosymmetric and all these vectors are symmetric, equilibrium holds for any weighting coefficients. Otherwise, they are to be found maybe by system of linear algebraic equations. Then we regard two examples. First of them illustrates contradiction between knowledge and wishes. It is a known rule of paranormal logic, not correct but often used. If A implies B and B is desirable, then A is true. And there are two rules. In more details, it was described in the paper. And another example is about approach, how to combine this model with analytic hierarchy process. We regard the rule A implies L, and we introduce states for the corresponding level related to each criteria, and then those criteria should be combined, and for combining criteria, classical pairwise comparison matrix can be applied. And again, equilibrium of alternatives is obtained if such pairwise comparison matrices among criteria is center symmetric. It is sufficient but not necessary condition, and it is important to find possible situations of equilibrium of alternatives when it is no symmetry. There are on this slide some parameters of the model are presented, and please, thank you for your attention. I am ready to answer your questions.
Thank you very much, but sorry, we cannot connect to them today. But he will be maybe accessible tomorrow to answer questions. His reports, it seems to me, quite interesting. And the problem of multi-agent decision making is an actual problem. Every approach is welcomed. Okay, and we have today one more report. Andrii Kopp, Metrolovsky, Serhii Orechov, towards understandability evaluation of business process models using activity textual analysis. Very interesting. Who will be?
Good evening.
Please, I
Good
will
evening.
give you possibility to share screen. You have.
Thanks. So I may start, and I'm glad to present here at this workshop our paper. You have already told its name. It's prepared by me, Andrii Kopp, and my colleagues, Dmitry Orlovsky and Sergey Orechov. And let's start with the business process modeling notation in general. Currently, business process modeling and notation, or simply BPMN, is a leading way to describe business process and, in fact, a standard for business process modeling. BPMN models describe workflows as sequences of tasks and events connected to each other using sequence flows. They also include start events and end events to signalize the beginning and finishing of the business process. Here is the basic example of a BPMN model. So the simplest BPMN business process includes events and activities. Here, events describe things that happen in an instant, and activities describe work units that have given duration in time. When creator makes a business process model using BPMN graphical notation, he or she should answer the following questions. When a new instance of the business process starts, for the start event, when the instance completes for the end event, and what to do on particular process step for all the activities along the process scenario. Usually events are named as combinations of nouns followed by verbs in past participle form, like order received, order fulfilled, message sent, and so on. But for activities, the verb object labeling style is recommended, so it should be given a verb in infinitive form followed by the noun, such as send message, submit order, process order, confirm order, and other examples. So the problem is that poorly designed business process models are hard to understand and use. They cannot be efficiently used to document business operations. They cannot be efficiently used to measure performance or find some bottlenecks that could reduce organizational performance. Existing studies mostly focus on the structural quality check for BPMN models using some metrics of the process scenario and respective thresholds to estimate their quality. But relatively smaller attention is paid to textual analysis of activity labels that are used in business process models, and for example, to check their compliance with the understandable style of labeling. And to solve this problem, we propose the approach. It consists of 4 steps, for which we have to process a BPMN file, analyze activity labels, and calculate the textual quality of a model. Then, in addition, we have to compute metrics and compare them toward thresholds to calculate structural quality. And finally, we decided to define the correlation between structural and textual quality and provide a recommendation for this point. So we started with the activity labels extraction, which is a relatively simple task. Each BPMN model is in fact an XML document. It includes the process tag as the core tag for this document with the subtags describing events, activities, and sequence flows. So it was a trivial problem to read such document and formally build the directed and labeled graph from the business process model. Then we proposed the activity labels analysis method. It includes several steps, as you can see in the algorithm here. So we have to start with the tokenization of each activity label to get bags of words that correspond to each of the business process activities. For each word of tokenized activity labels, we define one or several parts of speech to which it belongs. And then for each activity label, we check its length. And if the label consists of at least 2 words, we check if the first and second words are verbs and nouns correspondingly according to the perfect labeling style for business process activities. And then we calculate the textual quality metric as the ratio between the number of activities which labels match this verb-object style and the total number of business process activities discovered in a model. Then we also use the structural analysis based on metrics and thresholds. We use here the very basic structural metrics, such as number of nodes, start events, end events, and number of inclusive gateways, or known as OR gateways, for describing the branching logic of process scenarios. Then, using process modeling guidelines already known, we define how these metrics follow the rules using the thresholds. So there are rules such as don't use more than 31 nodes. In other case, the model will be too large and difficult to understand. Don't use more than 2 start and end events, or the model will be hard to understand where the process starts or where the process finishes. And don't use OR gateways because they could mislead readers and not correctly explain which exact path should be followed. And then using these values of structural metrics and thresholds, we propose to calculate structural quality as the average of inverse sigmoid function results as shown here in the equation. The experimental was performed using a data set of almost 200 models provided with the labels in English language. They were taken from open GitHub's repository by Camundus company. And these models describe various alternatives of goods dispatch, insurance recourse, credit scoring, and self-service restaurant business process. The software for perform such experiments was developed in Python using natural language toolkit module for NLP things and pandas module for correlation calculation and other modules to process XML files. And here, in general, the flow for the software includes activity labels extraction, tokenization, words tagging, evaluation of textual quality, structural metrics calculation, structural quality evaluation, and correlation calculation as the final step. So the obtained results allowed us to answer the question, does the structural quality of business process models affect their textual quality? And these results have shown that there is no relationship between textual and structural quality coefficients calculated for all of the experimental business process models. For example, here the business process model of high textual quality, all the activities has perfect labels that follow verb object style, but it has structural issue. It includes the OR gateway, which is not recommended to use for create the perfect comprehensible models. The second example shows the business process models of high structural quality. It perfectly follows all the metrics and their thresholds, but it has poor textual quality. 4 of 7 activities they mark it here as with the red rectangle has labeling style that doesn't match the recommended verb object style. So to conclude, we can say that structural quality of business process model doesn't mean its understandability. Demonstrated examples show how models of high textual quality can be of moderate structural quality and vice versa. And understandable business process models which are valuable for stakeholders should demonstrate both high textual and structural quality. And we recommend business process models pay for the textual quality and proper activity labeling as much attention as they pay for the structural quality of business process scenarios. So having a business process model both structurally and textually sound will make it serve its initial purpose to communicate necessary knowledge about current or planned business process. In future, we plan to implement the automatic correction of poorly named activity labels using maybe advanced some NLP and machine learning approaches, and continue the study of this relationship between textual and structural quality for business process models. Thank you very much for your attention, and I will be glad to answer the questions.
Thank you.
Thank you for. So,
can I ask a question? Some about BPMN 2.0, BPMN language, some XML-like language notation. It's your invention or it's existing?
No, it exists since 2011 maybe, and it's the most popular standard for business process modeling. wide world. And exactly this is why such standard of process modeling was chosen to perform this research.
Exist any API libraries to work with this BPMN?
Yeah, there are several of them, but for our particular case, we use basic Python's module XML because we had only to process it as the plain XML document. But I know the same company which repository we use to take sample models, it provides its own set of products, including libraries to process models for advanced processing and for some customization of their open source products.
Okay, it possible to use such notation for planning, for some more complicated processes with needed steps, decision making, and so on. And exist any how it will be engine for logical inference engines for check for consistency and so on, such model?
Yeah, there are. This model is widely used for complex process description to build models only to demonstrate as some workflows. And because of these models are also machine readable, as shown here, they can be executed by BPM engines or workflow engines and to automate some routine process like some step-by-step execution to pass one activity from one participant to another participant and so on.
Okay, it's interesting because XML-like notations exist many different and absolutely independent develops each approach, each notation. RDF, SVRL, I know two more spin and so on. It's all the same approaches to maybe business processes or business-like processes and modeling in graph, building graphs using such notation. Thank you.
Thank you very much for your questions.
Okay, thank you. I had a question about the business model link, but it's a bit complex, so I have to simplify it. So in software engineering, often patterns are used, and I was curious how often there are recurring patterns that you could recommend. So when you, for instance, automatically give recommendations how to improve, maybe there are some patterns for certain reoccurring business processes that are in many businesses used.
Yeah, there are some like basic structural patterns exist for BPMN models, like sequence, some branching, and others that describe what the patterns describe. Some oftenly occurred structural things, but in this research we didn't mention patterns yet. For comparing, for calculating the structural quality, perhaps it will be interesting to do it, and maybe thanks you for this idea, because as for patterns, it could be really interesting.
Yes, if there's
especially, yeah.
perhaps also mining for patterns in these data sets, if they are reoccurring patterns, to find your own ones by data mining of structural data might be also interesting in the next stage when you're going to make suggestions to prepare this. I think a pure NLP approach would be maybe a bit tricky to implement because normally you need to add some knowledge about the context. But yeah, deep neural networks can do surprising things sometimes, but I don't believe they can fully correct your business models. At least it's my, so you need big data sets to train them then. And in images we have them, but probably for business models, not sure if the data sets are big enough to train NLP models without adding additional knowledge. Okay, but that was my comment, and I think it's good to look for other knowledge representations also than automatic learning.
Thank you for your question and your comments.
Okay, so I think we are at the end of the sessions.
Yeah.
We have a round table now planned. I see there are the authors of the last paper present. We can do a round table if you like. Otherwise, we can also meet again tomorrow. It was a long day.
Yeah, it looks like nobody connects again. That will be all together on the panel next day, tomorrow.
Yes. It was improvisation, but we managed somehow in these difficult circumstances, and there can be, hopefully.
Sorry, we expected will be better situation when we planned our workshop. We don't know how it will be. Obstacles in Ukraine.
They're creating more and more obstacles, but yeah, let's tomorrow join again and continue this.
We should decide that it will be again on my.
Yes, I think so.
Okay, let it be.
We should again on yours. It worked well, and if there's a problem tomorrow, we will send email the same that we use for the PDF. I will send then my link. Then probably you can not join via the link. But
usually we have no problem with electricity here in my house.
Hopefully no attacks in the morning or stuff like this.
Yeah. It's attacks usually Monday, Tuesday, these days, not from Saturday, but nobody knows.
But we hope that everything will be fine and electricity will be
Let's focus on the science. And thank you for attending under these circumstances, and hope you also will have light. You don't have light right in the moment. Are you from Kharkiv?
Yeah, I'm from Kharkiv.
And is there in the moment also electricity shutdowns?
We have ones, and as in across the whole Ukraine. Especially after the latest attack, it was tough day this Wednesday.
So Kharkiv was also affected.
Yeah.
Affected. Oh, I didn't know because, So this is, what can I say? We cannot change the situation, but we can only try to do our best under these circumstances.
Yeah, we try.
Good. Okay, I hope to see you tomorrow again, and let's rest a bit after this day, and tomorrow we know the program.
Thank you very much for participation.
Thank you for the workshop. It was really great to participate, to listen other speakers.
It's interesting.
Hope to see you tomorrow.
Yes, same. Okay, good night.
Good night.
Bye.